We've talked about quantum computing before, but Microsoft created a quantum quake in the tech space last week. They announced a new quantum computer chip that took 17 years to make. The Majorana 1 uses a new topological core technology that reduces the error rate significantly and could create chips with as much as 1 million qubits of processing power per unit. Microsoft's researchers repeatedly created a new state of matter in the accompanying research paper published in Nature to help them create the method for increasing the power of the chip. Tom, we've heard quantum hype before. Is this the real deal?
You're going to need to take a shot of quantum and acid before you start digging into this. I'll tell you how I knew that people were talking about it. There was TikTok videos about what they did. So you know, if you've hit mainstream height, that's the way. First of all, these chips don't have 1 million qubits today. In fact, I would argue they're probably going to have 1 million qubits in 2 years. And remember that qubits are a measure of raw horsepower when it comes to processing in a quantum computer. They are not effective processing power because there's error correction. And that's important. So if you have not watched my quantum computing conversations video from a few years ago, you should totally go do that. Coming back, quantum computers basically work because you can take a photon and you can measure it and you can know every state of that measurement, right? It's not just 0, it's not just 1, it's all the states in between. The problem is that the error rate is very high on measuring photons because if they get bombarded by particles, they get knocked out of that superposition state, right? Here's what Microsoft did. They took 17 years to build a quantum wire that is 1 photon wide, and those photons are all entangled. So if one of them gets knocked out of superposition, the rest of them are still good, and you can observe that. I'm assuming that it took 17 years with a little pair of tweezers to put them all into one straight line. I'm a little skeptical of several things in this. First of all, the best quantum computers on the planet right now are still the size of a garage and require enough liquid nitrogen to float an aircraft carrier to operate. And that's to provide what I would consider to be a reasonable amount of quantum computing power. I don't know if they really did create a new state of matter. That remains to be seen because people are going to have to peer review this paper that they published in Nature. I will say that assuming that everything pans out and they weren't just sitting on this to make a big splash to change the conversation away from AI or what have you, there are massive implications for what all this means for people. I mean, the biggest one is one that I talked about in my video. This will invalidate public key encryption overnight, right? Like if it can really do that many qubits with error correction, it can instantly factor large primes. And thank God we put the quantum resistant encryption protocols in place. Thanks, NIST. We appreciate that. But more importantly, it goes on to solve bigger problems that don't have black and white answers, right? Like protein folding or signal analysis or stuff like that. But the problem is the same problem that we have with everything, because I'm sure that you've seen we have new treatments for Alzheimer's. There's, good cures for cancer on the horizon. But those are research projects with no practical applications yet. And yes, I know Satya Nadella held up a thing and showed it off, and here's what it looks like. And that is just a chip right now. That is a prop. That is no different than, I don't know, me holding up this jar of almonds as far as you're concerned. There's about the same amount of processing power in both of them as we currently speak. The real issue is going to be how they operationalize this and bring it from theory to practice. Because I promise you, you all remember a time in 2022 when LLMs didn't exist as far as you knew. When OpenAI was just a bunch of weird whiz kids out in Silicon Valley that didn't even have a product right now. We operationalized that very fast, but that was software. This is hardware. This is going to have to be manufactured and tested, and it's going to have to be built into things. And I don't know that we're ready for that yet. I hope we are at some point. I would like to see a fully functioning quantum computer online somewhere before I retire. But I don't know that we're going to get there yet. Al, do you think that I'm off base here? Are you excited about what Microsoft is doing?
So color me cynical, because back in 2018, Microsoft made a similar announcement. and then had to retract it.
Whoops.
And so the proof here is really back in that research paper published on Nature that talks about what the team actually did rather than the marketing spin that's been applied to it. Now, I haven't really spent enough time in quantum physics in the last 30 years since I did a physics degree at the University of Waikato here in New Zealand. Uh, but as I had read a little bit of it and read a little bit of analysis, there isn't even a single qubit being proven to be here yet. What I'd read of it was there was a suggestion that they had created this new state of matter that was theorized 80 years ago by, I can't remember his first name, but Majorana was the gentleman's family name. And that's why this chip is named after him. It's this new state of matter. The suggestion I had read was that what the team actually found was they'd measured something that corresponds to a Majorana particle, a particle that is its own antiparticle, which is kind of weird because we don't expect things to be their own antiparticle. So there's this possibly we measured the thing that goes on rather than we were able to ask this qubit to make some calculation and we got some data out. And I come back to correlation doesn't mean causality. Until, as you say, this stuff gets replicated by other people, until other people are able to actually replicate the measurement, and then it can be scaled. Now, scaling this is really where the magic is. If Microsoft can successfully use this technology that they've announced to produce qubits and produce particularly high density, high reliability qubits, then, as you say, Tom, the world is their oyster. Lots of things fall away. But I don't know that we're quite there yet. And I even saw some little scuttlebutt rumors that this announcement really shouldn't have come out based on the actual technology that's there. And we may see Microsoft walk this one back again, which would be incredibly embarrassing, particularly for the engineering team who are working so hard to advance things. And the marketing team maybe got ahead of their skis and announced more than was actually there. I really do hope this turns into some successful products that allow us to solve new problems. There are a lot of problems in material science and financial modeling where using quantum computing is going to be an unlocker for solving problems that we just can't practically solve now. But we're still, like you, I still have cynicism about this being close to being practically usable and able to do anything more than crack a 56-bit encryption key that we would have stopped using in the mid-1980s.
Yeah, I I really wish that companies would stop hyping new technologies like this with unrealistic outcomes. I mean, even just saying a million qubits, nobody knows what a qubit is, like right now, realistically. And for you to say you have a million of them, might as well be saying that you have, like, I don't know, like $1 million, right? Yeah, or a billion, right? You know, oh, I'll put 1,000 of these together. Um, the proof is in the pudding, the quantum soup, as it were. And I mean, Lord knows we're going to be talking about this for years, whether they retract it or not. But I don't think we're going to be using this in the foreseeable future, because I think that the support structures that will be need to build around it to utilize it to its fullest aren't even conceived of yet. And that's one of the problems we deal with technology all the time, right? Is just because you built a hardware thing doesn't mean that everybody's ready to use it. And the 5 Vision Pro users that watch our show will probably agree to that. So, I mean, we're going to talk about it.